Hi everyone, this is Hossein from EJ Academy and I'm back with another video. This video is about interest. So before getting into details of calculation of interest, I wanted to give you two examples. In these two examples, I would like to introduce two situations that in these two situations you wanted to know interest, you care about interest. So in the first example, assume this is a bank. So this is a bank and this is you, and you look happy. And the reason that you look happy is that you have some money and you want your money to grow, so you decide to invest your money in the bank. So you wanted to invest your money, you take your money to the bank, and the bank tells you that they're going to pay you interest, so your money will grow over time. And you ask the bank how much your money will grow, and they will tell you their interest rate. And the interest rate is usually per specific period. Let's assume this is like annual interest rate. It means that the interest is going to be paid every year. And usually interest rate is expressed as either percentage, let's say 5%, or it is expressed as the decimal. Let's say it is 0.05. There is another scenario that, again, this is you in that scenario, and you wanted to buy a car or a house and you need some money. So you go to the bank and you ask for that money, and basically you borrow the money from the bank. So you get your money and you're happy, but then when you wanted to return the money to the bank will tell you that in addition to the original money that you have to return, you have to also return the interest of that money. So you have to return the interest to the bank. So the money that you have to return is the original money plus the interest. And that makes you sad, actually. So in these two situations, you care about interest. You wanted to know how much interest either you get paid or you have to pay to the bank. Now let's assume that you are the happy guy, you have the money, you wanted to invest in the bank, but you are also smart. So you ask the bank agent that what kind of interest they're going to pay you, because you know that there are two types of interest. One is simple interest and the other one is compound interest. In case of simple interest, the interest rate is only applied to the original money. I'm going to use an illustration here to help you better understand this. So let's assume this square here is the original money that you invest in the bank. So this is the original money. This is also called principal. Let's call it P here. And the interest rate I is 5% or 0.05. And since this is a simple interest, this interest rate is only applied to the original money. So after the first year, this small square is the interest. So at the end of the first year, you have 0.05 times P. And at the end of the second year, you have the same amount of interest. So this is the interest that is paid to you by the bank at the end of the second year. It is also 0.05 times P. And this will continue. On the other hand, where we have the compound interest, let's assume you have the same original money. So the size of the square is the same. The amount of original money is P, and the interest rate is also the same. So I is equal 5% or 0.05, but this is a compound interest. That means that this interest rate is not only applied to the original money, but also applied to the interest that you made during the previous year. So at the end of the first year, this is the amount of interest that you make. So at the end of the first year, the interest is 0.05 times P, the interest rate applied to the original money. So it's the same as simple interest, but at the end of the second year, your interest is a little bit greater. So at the end of the second year, the 0.05 or 5% interest not only applied to the principal money, but also applied to the interest that you made at the end of the first year. And this will continue. So in case of compound interest, your money grows faster than the simple interest. To see how much faster the money will grow in case of compound interest, let's assume our happy guy wanted to invest $100, and let's calculate the total money after 10 years. I'm going to draw a table here. So here in the first column, we're going to have the year number. In the second column, we're going to calculate the total money for simple interest. And in this column, we're going to calculate the total money for compound interest. So at year 0, at the beginning, the principal is $100 and the interest rate is 5% simple interest, or 0.05. So in case of compound interest, it's the same situation. The principal is $100 and the interest rate is 5%, but it is compound interest. At the end of year 1, in case of simple interest, the total money F equals the principal plus the interest, which is 5% of the principal. So this term here is the interest. And if we factor out the common term P here, we're going to get P times 1 plus 0.05. So assuming P is $100, the total money would be 100, open parenthesis, 1 plus 0.05, close parenthesis, and if you do the math, you're going to get 105. So in case of compound interest, the total money F would be the principal plus the interest, which is again 5% of the principal. So the interest is the same, and if you simplify this expression, you're going to get P open parenthesis 1 plus 0.05 close parenthesis. And for the $100 principal, you're going to get 105 at the end of the first year. So as you can see, at the end of first year, the total money is the same in both cases. Now let's go to the second year and see what happened at the end of the second year. So year 2, in case of simple interest, the total money would be the money that was in the account at the end of year 1, which is this money right here. So we have this money here, P times 1 plus 0.05, and we're gonna have the interest. The interest is 0.05, and it is applied to the principal only because it's a simple interest. So this part here is the interest, and this part here is the money that was in the account at the end of year 1. So we have a common term P in both, and then if we simplify this, we're going to get P open parenthesis 1 plus 0.05 plus 0.05, and if we further simplify, we're going to get P times 1 plus 2 times 0.05. And the reason that I wrote P in green is because we are at the end of the second year and we have a multiplier of 2 here. In case of compound interest, the total money F would be the money that was in the account at the end of year 1, which is this money right here. So P open parenthesis 1 plus 0.05 plus the interest, which is 5%, and since this is a compound interest, this 5% is going to be applied to the whole money that was in the account at the end of year 1. So the 5% is going to be applied to P open parenthesis 1 plus 0.05. So this is the interest, and this is the money that was in the account at the end of year 1. And we have a common term P open parenthesis 1 plus 0.05 close parenthesis here and here, and we can take that out. So P open parenthesis 1 plus 0.05, and we have 1 plus 0.05 close parenthesis. And if we further simplify, we're going to get P open parenthesis 1 plus 0.05 to the second. And again, as you can see, I wrote it in green, and the reason is because this number 2 is matched with the year number. Let's fast forward to year 10. Year 10. So in case of simple interest, the total money would be F equals, if we follow the same pattern, we're going to get P open parenthesis 1 plus 10 times 0.05, and this multiplier 10 matches with the year number 10 here. Assuming P is $100, the total money would be 100 open parenthesis 1 plus 10 times 0.05, and if you do the math, you're going to get 150. So in case of compound interest, the total money F would be P. Again, I'm going to follow the same pattern that I obtained at the end of year 2. So I'm going to have P open parenthesis 1 plus 0.05, which is the interest rate to the tenths. And replacing P with $100, I'm going to get $162.89. So as you can see, in case of compound interest, the account made $12, extra $12.89. If we follow the same pattern, we can obtain an equation that gives us the total money in the account after n years. So at the end of year n, And in case of simple interest, if the total money equals P, the principal, open parentheses, 1 plus N times I, close parentheses. In this equation, I is simple interest rate, and it is in decimal. N is the number of years. P is principal. And F is total money after N years. As you can see, inside the parentheses we have two terms. The first term is a multiplier that represents the original money. And the second term is a multiplier that represents all the interests paid to the account over the course of n years. On the other hand, we have compound interest. And the equation that gives us the total money for compound interest is F, the total money, equals P, the principal, times open parentheses 1 plus I to the nth. In this equation, n is the number of years, I is compound interest rate, and it is in decimal. P is principal, and F is total money after n years. For better comparison, let's graph these two equations. I'm going to assume P is equal to $100 and I is equal to 0.05. Also, because in Desmos we have to work with x and y, I'm going to replace n with x. I'm going to assume n is my independent variable, so n will be on the horizontal axis. And I'm going to replace f with y, and I'm going to assume f is my dependent variable, so it will be on the vertical axis. So in case of simple interest, this is my equation. Y is equal to 100 open parentheses 1 plus 0.05 times x. And in case of compound interest, this would be my equation. Y is equal to 100 open parentheses 1 plus 0.05 close parentheses to the x. Let's head over to Desmos to see the drawings. Here in Desmos, I have entered the two equations. The first equation in blue represents simple interest, and the second equation in orange represents compound interest. As you can see, the second equation is an exponential equation and it grows faster. In case of simple interest, the blue line, after 10 years, the amount of total money in the account is $150 as we obtained from the equation. And in case of compound interest, since it's an exponential equation, we got a higher number. So after 10 years, the total money is $162.89. Let's recap what we covered in this video. We had an original money with the amount of P. And we wanted to invest this money into an account that pays interest, and we wanted to calculate the total amount of money in the account after 10 years. We had two options, and one option was to invest this money into an account that pays simple interest rate of I equal 5% or 0.05, and we knew that in case of simple interest, the interest rate is only applied to the original money. So the total money in this case after 10 years was the original money plus all the interest added to the account, which was 0.05p after the first year. So this was the interest paid to the account after year one, and then another interest of 5% of p added to the account at the end of the second year. And this continues until year 10, that the account is get paid another 5% of. So this is the interest paid to the account at the end of year 10. So if we simplify this equation, we would get p plus 10 times 0.05 times p. And then if we further simplify this, we would get p times 1 plus 10 times 0.05. Another option was to invest this money into an account that pays compound interest rate of I equal 0.05. So the interest rate was the same, but it was compound interest, and we knew in case of compound interest, the interest rate is not only applied to the principal money but also applied to the interest paid to the account during the previous years. So we calculated the total money in the account like this. F would be equal to P, the principal, times 1 plus 0.05. This is the total money in the account after the first year. And at the end of the second year, we had another multiplier of 1 plus 0.05 because the interest rate is applied to the whole money in the account and not to the principal. So this was the whole money in the account after the second year. And this will continue until year 10, that we get another multiplier of 1 plus 0.05. This multiplier of 1 plus 0.05 applied to the whole money in the account. So this is the whole money in the account at the end of year 10. And if we simplify this, we would get P times 1 plus 0.05 to the 10th. And we concluded that it's better to invest our money into the account that pays compound interest because our money grow exponentially. And that was it for this video. I hope you enjoy and learn something from this video. If you have any questions, please leave them in the comment section below this video and I will get back to you as soon as I can. If this video helped you in any way, please hit the like button and subscribe if you enjoy our content and would like to see more.